let's begin. Yeah. Hi everyone. Hi Rene. It's a great pleasure for me to introduce our guest speaker today, our great speaker, Rene Kizilcec. He's an assistant professor of information science at Cornell University. And he's also a founding director of the Future of Learning Lab also at Cornell. So he studies really cool stuff. He studies how digital technology in education is used and which impact does this technology has on like how people learn, how different groups learn, how they use online courses. Is there any inequality in how people use this technology? Is it really like democratizing education, or there are still some inequalities in accessing these online courses and how people use these opportunities? So I was really happy when Rene agreed to give a talk, because yeah, he proposed to give a talk about randomized experiments, field experiments in online learning. And I believe that it's a great addition to the program, because we don't have anything on experiments. And this is a really important topic. So yeah, I'm happy, we all are happy that you could make it. Without further ado, I will give the floor to you. Just one quick comment. So here we have participants of our school 6 HSE, but some people from other schools, they were also really interested to take part, but we have some intersections in our schedule, so I'm not sure if they will come, but maybe we'll come for like 30 minutes, so don't be surprised that they will come and then go. So it's not because of us, because of you, it's because they can make it only, maybe they could make it only for like 30 minutes. So yeah, I hope that it's not a problem. Okay, so the floor is yours. Yeah.
Sounds great. Thank you, Lisa, for the kind welcome. And it's my real pleasure to come and speak to you and address you and share some ideas with you. And, you know, this group is small enough, at least for now, that we can have some conversation. And so you should feel free to interrupt me at any point in time. I'll ask you to jump into the chat and share some ideas at a few points during the presentation. But this is really your time. And I'm here to just provide some ideas and make this a good learning experience. So I'm glad that there. In fact, one of the things I'd love you to do to get started is to post in the chat what your name. I see your name, but tell me a little bit about what stage you're at and what your research topic is. I'd love to know that. I'll look at it while I get started here. So let me just share these slides. Can you see the slide deck?
Yeah, yeah.
Great. So I'm just gonna minimize this. All right. So I decided to talk about randomized field experiment. As Lisa said, it's something that I didn't see on the program. And I think it is an important part, more and more so, of computational social science today. I will make a note of the clickstream data topic of this subsession, and I'll start by talking a little bit about clickstream data, and then transition into randomized field experiments. So clickstream data, I would say, is very plentiful, but it is also insufficient in a few important ways. So here's some example of what clickstream data tends to look like. You have events that have a timestamp usually, and maybe some metadata that is associated with them, including who performed that event. So why do I say it's plentiful yet insufficient? And so I want to start off by, to warm up the audience here, to get you to put in the chat some of the things that you think make clickstream data plentiful, that make it that is an advantage of clickstream data that you can get from it. So feel free to type those into the chat right now. Yeah, Ivan notes the high time resolution. You see every single event rather than very spaced out points in time. What else comes to mind? What is it about clickstream data that makes it very useful to you? Low reactivity, right? As you perform the events in the environment, you don't necessarily feel observed. And even if we do have some kind of consent form at the beginning, people usually tend to forget that they're being observed in online environments, for better or worse. And so there's much less reactivity than, for instance, in interviews or when somebody's sitting there observing you. So those are certainly two great examples. So let me show a few. Oh, there's one more. Great. Easy to see changes in behavior after an intervention. Yeah, right. You perform an intervention, you can look at the click stream and see what happened in great detail. And Lisa also notes that it's always on, right? Clickstream data, you don't have to go in and measure it. It's measured all the time once it's implemented. So those are some great reasons for why it's plentiful. Here's some that I noted that I think echo the ideas that you have. One that I didn't see is the fact that it's very scalable, right? Interviewing people or measuring by hand it takes a long time to do it for many people, right? Not only do you get a lot of resolution for each person, but you can also look across many people. And so that data it provides is really useful for doing various kinds of modeling, whether it's predictive modeling or other kinds, because it's so big and because it is so plentiful. Now, clickstream data is also insufficient to perform certain tasks and to get certain insights, scientific insights. So put in the chat what you think are some of the limitations of clickstream data that are important to note, especially for social science research. Okay, Timur notes that it can be messy and incomplete. Absolutely. Anybody who's had to clean clickstream data will appreciate that. Lisa notes that context data is sometimes missing for the users, or it is there, depending on how you want to look at it. But very often we don't know what the context is in which users are leaving those traces. There might be bots that are leaving clickstream data. That's certainly more and more of a concern these days in distinguishing bot behavior versus real human behavior. There can be duplicates of users. It goes back to the messiness of cleaning up clickstream data, right? So here are a few, and I see Nora notes that it can also be unbalanced, right? So you might get a lot of data on certain behaviors or for certain people, but very little for others because of how they engage in the environment, for instance, or how the environment is set up. So while clickstream data is powerful for finding patterns, there are a few things that are insufficient about it, right? The data we see is not inherently meaningful, right? The fact that there was a click on something or an event was recorded it is not something necessarily that we would otherwise measure. It is a behavior, and that behavior could mean many different things. For instance, in online learning environments, there's a lot of clickstream data of learners opening pages that contain lecture notes or videos or assessments. Does that mean that they really read those? Does that mean that they really engaged with those materials cognitively? We don't know, right? But we see the click. And so there's a sort of a jump from seeing them click on it to them actually engaging with it. And that's important to remember, that what we observe is not what we might want to observe, but it's an abstraction of it. It depends a lot on the instrumentation, right? The way that the platform providers, the engineers who created the logging system, decided to implement what gets logged and what doesn't and how it gets logged, really informs what you get at the end of the day. And that's not a decision that is objective. It's very subjective as to how to set that up. And if you've ever created a platform, you'll know that decisions go into what exactly you log and how you log in. What we heard before in the chat is there's a lot of contextual information missing, which can affect the behavior, right? What environment is somebody in when they perform the behavior? Who are the people who are performing the behavior? Those information are important, including information about how the platform looked at the time that the data was collected, right? You all know that digital platforms tend to evolve over time and they start looking differently. And those changes can have a huge effect on how people are behaving, right? If you just remove a button and you make it a little harder to find to get to a certain page, suddenly clickstream data will look very different as a result of that, right? So when you look backwards, it's always important to remember that the platform may have looked different at the time when that data was collected. And so clickstream data, I would argue, is insufficient often for explaining those patterns that it can discover and for explaining relationships between different variables, right? And that's in part why I decided to talk about randomized experiments and the value that they bring. And they certainly can be used in combination with clickstream data, right? And that's what we've done a lot in the context of online learning environments and what many computational social scientists do when they use randomized experiments. And so let me give you one example of what I mean here, which is in the context of self-regulated learning in online courses. So one of the things that we found out relatively early was that those students in courses who were good at self-regulating their learning, they made plans, they set themselves goals, they strategized for how to accomplish the tasks in the week, right? The kinds of things that good students do, right? They are on top of the work that they need to do. Those students tended to do quite well in online courses compared to those who didn't do that, who were behind, who didn't engage in careful planning as to how to complete the work that they need to complete for that week. And so the way we first found that was by looking at clickstream data. Right? We looked at how people were behaving and how those patterns in behavior were correlating with important outcomes such as completion of the course or the grades that students got. Right? And there were some very clear patterns that showed that the two are correlated. People who do more, do it in a timely manner, they tended to do better. But that might also not be surprising, right? Those who do more, and then they get a certificate at the end, right? So at some point there was even a paper published that kind of made fun of all the discoveries about how those who do more isn't really great science. And so the literature really moved into a few different directions. One was to combine survey data with the clickstream data. Right? So people used established survey measures of self-regulated learning, which had been around way longer than clickstream data analysis of this kind of environment. And they asked, how much do you plan ahead? How much do you find an environment in which you can learn the materials quietly without distraction, and so on and so forth. And they connected those survey data with the clickstream data and found certain connections, right? And found where there's overlap and where the survey data also predicts outcomes down the line, completion and so on. The other direction that researchers took it was to conduct experiments, right? They looked at what were the kinds of behaviors that successful students exhibited based on both the behavioral logs, the clickstream data, but also interviews of students and what they were saying about how they were approaching the course. And they conducted an experiment where they showed that to the students in the course and said, hey, here's some tips on how to be successful in the course from previously successful students. These are the kinds of behaviors that successful students exhibit. Right? Now, surprisingly, or maybe not so, that did not work. Telling students just the tips of how to be successful did not make them any more successful than those who did not get the tips in a randomized experiment. Right? And so it allowed us to understand how providing those kinds of recommendations based on clickstream data and interviews, whether that has an effect or not on students. Right? And some of the studies that I'll be showing you show instead that what does help is taking students by the hand, giving them the resources they need in order to perform the kind of planning, the kind of goal setting that students were engaging in who were successful, right? So it's not so much that I need to tell you, you should make a plan, but that I tell you, okay, now make a plan. Here's the box. I'm giving you some tips for how to make a good plan, but make it right now. That is what actually helps students do better in the course. And so that relationship is hard to glean from clickstream data alone, but it's something that you can understand more once you look at experimental data and you conduct the experiment to understand what does work and what doesn't work. So I'm going to give you an overview, and then I'm going to go into a number of examples that I think exemplify different techniques and that I hope will give you an idea of what kinds of techniques you can use when you conduct an experiment, right? Or when you see a platform where you might want to conduct an experiment. There's a lot of ways you can approach it, right? It's not just A/B testing with simple randomization. And so I want you to appreciate the different kinds of experimental designs that are out there and see for yourself how they could be employed. And maybe you'll come across an idea as a result of it that you can then pursue, hopefully. The place to start, though, is a really fundamental one. And I think it's important to come back to it, which is that experiments help us discover the what if, right? What if we did this? What if somebody did that? And thereby they help us overcome the fundamental problem of causal inference. Do people know what the fundamental problem of causal inference is? What I mean by that?
Unobservable confounders.
Sorry, say that again.
Unobservables, like the effects of unobservables, so omitted variable bias or confounders.
Okay. When you say unobservables, what say a bit more what you mean by that?
Just the variables that we cannot control for. So it's usually we need some exogenous variation in the variable that we think has an effect. And very often it's hard to, in field experiments, it's hard to prove that it's actually as if at random. So we assume that it's as if at random.
Okay, yeah. So that's what you describe is an excellent description of quasi-experimental designs where we're trying to find something that is, as you say, as if random because of some variation that was induced. And I'll get to that, to a few different examples of that in a second. This one is actually much more simple than what you jumped to already, which is that the fundamental problem is, and I thought you were getting at it with the unobservable part, is that if you are in the treatment, I don't know what you would have done in the control. And if you're in the control, I don't know what you would have done in the treatment, right? We only get to observe each person, each unit, in one or the other scenario, right? We can't go back and sort of put you in the other one and see what happens, right? Which is the ideal case of what we would want to know, right? And so that's what's often called the fundamental problem of causal inference. And experiments get around that. Does anybody know why assigning people randomly to different conditions and giving them the different treatments, why that gets around this problem, or how it does?
Because the personal characteristics don't correlate with the treatment, with being assigned. If it's randomly assigned, then it doesn't correlate with the treatment.
Exactly. So what happens is that you will get two groups, right? Those in the treatment and the control, that look similar based on what you can see, right? You might look at the gender ratio maybe in the two groups, and it's 45% in both groups. You might look at a few other things that you know about, and you can compare them, and they'll be on average similar. But more importantly than the things that you do observe, there's a lot of things you can't observe. And those are usually where you get in trouble, where things get difficult, because you don't know if maybe the people in the treatment might have a lot more motivation to complete a course than maybe those in the control for some reason, right? But if you randomize them, then on average, you will have the same level of any variable in both of those groups, right? So the correlation between the assignment and any variable is on average 0, right? It's an expectation 0. And so that is the beauty of randomizing units to treatments, that you don't only get balance on the things that you do observe, but also on the things that you don't observe, right? On average, right? So what it does, it moves us away from being able to see how one person performs in one condition on the other, to being able to see how the average person in one group performs to the average person in the other group, right? So we move from individuals to averages, but as a result, we can get over this fundamental problem of causal inference. Let me know if you have questions, because I think it's an important concept to appreciate for designing experiments, sort of why we do it in the first place. So there are many ways of achieving this, and I'll just review a few of them, and I'll tell you a little bit about which ones may be more relevant than others in the context of online platforms where you might be conducting experiments. Right? So the first and simplest one is simple random assignment. It's a coin toss, right? It's a Bernoulli trial. If there are two conditions, you just toss a coin and you put people into conditions. Now, one of the downsides with that isn't really a big deal if you have a large sample size, is that the groups that you're assigned to might be different size, right? You might just get a few more people in one condition than the other. And so one of the ways to restrict that is to use complete random assignment, right? Where you know the number of people in advance and you make sure that exactly 50% are in one condition and the other 50 in the other condition. Or if you have three groups, 33.3% and so on. So that's one thing. In practice, if you have large enough data, there isn't really much advantage of using complete random assignment, right? And it is usually a headache because you need to know who is in your sample in advance as you randomize. And if you have any attrition, people dropping out of your study, then you're once again left with unequal sample sizes, right? So while in theory it's interesting, and if you have a small scale setup, it can be a good idea. In practice with large data, it doesn't really make much sense to try. In contrast, stratified random assignment is a little bit like complete random assignment or simple random assignment, but you look at strata defined by characteristics that you know. For example, if you're doing a study where you're interested in the effects of some intervention on different groups of students, right? For example, in the US, we look a lot at how interventions to support student success affect different racial and ethnic groups, right? And you might have a group that is underrepresented. So you want to make sure that in that group that is smaller than the other groups, you have a good balance between those assigned to the treatment and those assigned to the control, right? You want to make sure that not accidentally you've got most of those people in that group be assigned to one condition and not the other. Stratified random assignment is the way to go then, right? You can say among the people in that group, right, say underrepresented minority students, I want to make sure that 50% are in the treatment, 50% are in the control, right? Or you randomly toss a coin within that group, which isn't as good, but still can help make it a little better. So you can control, and you have enough power, statistical power, in order to do the analysis for each group in your sample. So that can sometimes be a good idea. We used that in a relatively large study, and we eventually abandoned it. Because one of the things you need to consider is that you cannot analyze the data as if you had not done this, right? If you do this, if you use stratification or blocking, you need to consider that in the analysis. And I'll get to why in just a second. Another much more extreme case of blocking or stratified random assignment is paired random assignment, right? And the idea here is that we're trying to get much closer to the original goal of seeing the same person once in one condition and once in the other condition, comparing them. And the way we get closer to it is by finding people who look alike, or units who look alike. The unit could be a person, a student, could be a classroom, could be a school. And you pair them up initially, right? You find the students who have similar grades in the past, who might have similar levels of motivation on some survey measure. And you then randomly assign one of the students to one condition, the other student to the other condition, right? This is paired random assignment. And so the advantage there is that you find people who are alike and then you assign them. Unlike the other approach where you have these two big average groups, right, which could include people with all kinds of motivations, and you randomly assign people into these big average groups. The last one that is notable is cluster random assignment, right? This happens when you have clusters defined by, for instance, classrooms, sections, schools, any group of individuals where you're interested in the individual outcome, right? What is the student grade, or does the student drop out of college? But for often logistical reasons, you cannot assign the individual student to condition, maybe because the teacher is the person who gives out the intervention, and the teacher cannot sort of divide the classroom up, so it has to be at the classroom level. And so you have a cluster random assignment where you try and get the classrooms to be looking alike when you assign to treatment or control. So what is important when you consider these different kinds of assignment mechanisms is many things, really. But the one thing that I think is important to note is that the analysis, depending on which approach you use, changes. And some of them are easier done than others, right? So one important piece you need to know is the information that is required at the time that you're assigning in order to perform a certain assignment, right? If you want to do paired random assignment, you need to know something about the individuals, the units that you're assigning in advance so that you can pair them up, right? And sometimes that is available. And if it is available, this might be a really good idea in order to increase your statistical power. But if it isn't, then you probably can't do it. Simple random assignment will always work. And it's, in large samples, it pretty much works perfectly fine, right? Many of these techniques help you if your sample is smaller or high variance, right? People are very unalike in many ways, and you want to compare people who are more alike to each other. These techniques can help you achieve better power. Now, I keep saying that, it helps in the analysis, you get more power. A simple way of thinking about that is to consider how many possible assignments there are, right? So if I do simple randomization, right, I could assign people many different ways to the two conditions if there are two, right? If I do complete random assignment, there's a lot fewer ways of assigning people to conditions because I need to have a 50-50 split exactly, right? So that reduces the number of possible assignments. And if you keep going, it goes lower and lower with these different kinds of assignments. Now, that matters in the analysis, right? Because when you calculate test statistics like p-values, the idea is that you're calculating how likely or unlikely a certain outcome is given all the ways it could have gone, right? That's sort of one way to think about it. But that last part of the different ways that it could have gone, the different ways it could have turned out, changes depending on the kinds of assignments that are possible, right? If I have a paired random assignment, then for each pair, it could have gone one way or the other way. That is all, right? There's just two ways for each pair of people. And so you have a much smaller distribution, null distribution, that you're comparing your statistic to. And so, that is why these different assignment methods have an impact on how much precision you can get out at the end of the analysis. And if I would love to go into more detail on this because it's really interesting and looking at the different kinds of ways of assigning. But one place that I recommend where you can read up more on these kinds of assignments and why exactly they provide advantages in precision is, for example, this recent book by Hido Imbens and Don Rubin on causal inference. There are many books that cover it. I think this one does a nice job in doing so.
Can I just ask a quick question?
Yeah.
So this point that you just made about you want to have more potential permutations, right? I mean, this is important to the extent that you're doing randomization inference. But if you're just doing sort of normal frequentist statistics, does that matter?
Yeah, it does. In the sense that you, so yes, if you do randomization inference, you'll see it very clearly. And I'll show you an example of that actually in one of the studies, the examples. But you can also see it in other places because you can analyze these designs using different methods. Actually, the book goes over that in a nice way to show what the differences are. For instance, paired random assignment, you get a much more efficient formula for the standard error, and therefore for the confidence interval, right? Because of the design of the study, right? And so you even though you're not using randomization, for instance, in the classic sense, you still get to use a different way of computing your standard error than you would otherwise, that takes into account the design that you used, right? Another example is if you use stratified random assignment, right? You can enter, you should enter at the very least the things you stratified on into your regression model. And there are other ways to account for the fact that you stratified, right? But those will in the end help you, reduce the standard errors. Usually, right? Normally, that will be the case. And they will be at least as large, at least as small as they would be otherwise. Right? And so even though you're not using classic randomization, which is limited in the way you can, control for other variables that you might want to add in, it still provides an advantage because the design matters, right? The design of your experiment matters for the analysis later on. And I think I guess that's why I'm making this point, because it is often forgotten that the design matters. And it, frankly, if you're Facebook or Google and you've got, millions of units that you're randomizing, this might not matter as much, right? This might not give you any big advantage because the sample size is so large that this will be, it'll outweigh any of these design factors. But if it isn't that large, and I'll show you some examples, depending on the unit that you're randomizing or the limitations that you have, it can actually provide you some big advantages to get enough power in an environment where otherwise you wouldn't have enough power. Does that address your question?
Yeah, I guess that none said that. Yeah.
Great, perfect. Yeah, and feel free to jump in. I now increase the window size so I can see if hands are raised. All right. So one other point on this that I think is important to make, and you should forgive my reference here, is that there are many ways of randomizing, but there's also many possible randomizations, right? And they're not all equally good, right? Balanced assignments, right, where you have a randomization that balances on observables, right? You don't know the unobservables, but for the ones that you do observe, balances tend to be quite alike, right? Because there's only a few ways of being balanced, right? You've got a certain number of variables, right? Say you've got gender as one of them, and if you have 49 in one and 48 in the other, that's pretty close, right? You might get to 49%, and that's it, right? And there's a few ways to achieve that. But there's a lot of ways in which your assignment could be unbalanced, right? In which you have slightly more women in one group, slightly more men in the other group, and many other ways of having unbalanced assignments. And the good news is that this is easy to check, right? If you have the data, the observables in advance, you can see how good your assignment is, and you can do something about it if it's not good, right? Namely, re-randomization. There's nothing wrong with randomizing again. In fact, there's nothing wrong with randomizing many times and then choosing a randomization that is very good, right? Because this is how you're assigning a unit, and you want the groups to be very alike, right? That's sort of the idea behind some of the matching analyses that are out there, right? Where you try and find people who look alike so that you can do some causal inference in a quasi-experimental way. So that's another point that's important, right? There's many randomizations, but it's also to, perfectly okay to look at those randomizations, see how good they are, and to re-randomize until you get a good one. Because you usually only get one shot to run your experiment, right? And many of the guarantees that randomization provides are only in expectation, right? But that doesn't really matter for you because you just get one shot. So the fact that, if you did it 1,000 times, it would be nice and balanced on average is no good for you, right? Because you only get one. And so re-randomization helps you make sure that that one is a good one. So one other point I want to bring up is encouragement designs. They are still randomized experiments, but they are the kind that you would use if the behavior you're interested in is not something that you can manipulate directly, right? So one example is smoking. I can't make you smoke, but I can give you incentives to stop smoking, right? I can pay you money if you stop smoking or something like that, right? I can't make you exercise, but I can give you a free gym membership or something else that would encourage you to exercise. And that is what's often used in those kinds of situations where the behavior of interest is something that can't be directly manipulated, which is often the case in online settings and online platforms, right? I can't make you comment on my posts on Facebook, but I can make it easier for you to write something so that it's more likely that you will comment on my post on Facebook, right? Now, that is a really useful technique to keep in your head as you think about experimentation. Just note that it requires some special analysis, right? You can't analyze it as if it were, as if you were directly affecting the behavior, right? And I can go into more detail if you have questions about that as well. So here are the natural and quasi experiments that were mentioned a little earlier. And so, if you're wondering, is it a natural or quasi experiment? Ask yourself, who controls the assignment to conditions, right? What's the source of people being in different conditions or assigned to different treatments, getting different treatments? If it is something completely random that just happened, nobody really controlled it but nature, it's a natural experiment. If it is some process that is maybe arbitrary, that somebody put in place, not realizing that it would create an experiment, it might be more of a quasi experiment. And there's everything in between those two. So here's just a few different examples of quasi experimental and natural experimental settings that you could exploit in trying to understand trying to perform causal inference. So one is randomness in some selection distribution process, right? So you might be randomly selected to get a prize, to get a resource, and you could look at assignment to sections in a class, right? Some might get more experienced section leaders or section leaders with certain characteristics, and as long as it's random, you can look at that. Assignment to dorm rooms has been used in several studies to understand peer effects, for instance. You can also look at sudden shocks, and I think COVID-19 is a good example of that, although COVID-19 also has its limitations in terms of how precise of a shock it was, right? It was a very sort of universal shock. It changed so much at once rather than sort of one particular thing. And so that's one of the limitations it has. You can look at discontinuities, right? So if you maybe only get into a program if your grades are above a certain level, right? So you could look at that discontinuity. And you can look at instrumental variables, right? And I'll show you an example of how that was used. Essentially, you've got something that correlates with the desired behavior, and that desired behavior, you're looking at the effect on some outcome. But the important thing is that the instrumental variable is not directly associated with the outcome itself. And I'll show you an example of what that looks like in the case of online education in a second. This is by no means all different designs, but these are some of the common ones. Another common one that isn't on this list is matching analysis. So where you have a big observational data set and you're trying to perform causal inference by finding people who look alike, right? Just like the idea of, to overcome the fundamental problem of causal inference, you find a person who looks like another person, but one of them got the treatment and one of them got the control. And so you can compare them, right? But the difficulty there is you don't know how they vary on things you do not observe. Maybe some of the things you do not observe are actually quite important. The last point before I get to some examples is about estimating treatment effects. And we've seen a trend in recent years away from only focusing on the average treatment effect, right? How is one group affected by the treatment on average compared to another group? And I think that's a really useful trend, because one of the issues with just looking at averages is that it can hide how subgroups are affected, right? So going back to our example from before, where we've got a small minority group in an educational setting, an intervention might work really well for the majority group, help them get better grades, help them persist more in college, but it might actually not do anything for the minority group, or even harm the minority group to an extent, right? And you might not see that if you just look at the average treatment effect. It might be hidden. And so that's just one of the reasons why it is important and useful to look at subgroups and understand how are these subgroups affected. What's necessary for that, of course, is that your sample size is large enough, right? It's not really helpful if your subgroup is just 10 people, unless you have a really strong experimental design where those 10 people were, was like a paired design with repeated measures or something like that. But so that's the thing to consider there, right? Do you have enough power in order to understand effects on that subgroup? There's a lot of nice methods out there now that help you find heterogeneous treatment effects in a case where you don't know where you would expect them, right? If you have a lot of different characteristics on people and their contexts, and you just want to see, is there any heterogeneity? And that might sometimes be the case. But if you know what the important groups are, right? If you know that there are certain students who have been underperforming in the past, and you want to make sure that they are helped by the intervention at least as much as the students who have been doing well, you can just look right for that. And you don't need to necessarily sort of use fancy methods that try and discover heterogeneity, right? You can just go look for it exactly. The other piece to this is to understand how the effects are distributed, right? So this is looking at the outcome itself and understanding how people were affected, not just who was affected, but in what ways they were affected. So one example is we did some interventions trying to encourage students to take courses, college courses outside of their major, right? To go explore different subjects in the arts and the humanities. And so there we looked at which courses did they actually go and take, right? We nudged them, we had an encouragement design for them to go out and take courses. We could look at who was more affected by that encouragement. But then it's also interesting to see, well, and where did we encourage them to go? Are they going to take engineering courses, or are they going to take philosophy courses, right? I guess it's not hard to guess the answer to that question. They were all taking engineering courses, but it's important to understand that, right? And it's sort of another kind of heterogeneity to consider in the analysis, right? That you can in some cases look at, right? If your outcome is completion, then maybe there's less to discover that, but something to keep in mind. All right. Any questions so far on anything that I covered? I hope all of these themes will come back in some of the examples that I'll give you. All right. If not, I'll move on and give you some examples. Okay. So this is an example close to your home. This is a platform that provided MOOCs, and we use it in an experiment in order to understand how college campuses could lease those courses and use them in order to provide a hybrid or a completely online experience, right? And we looked at the outcomes of it. So this is a national course platform, and we recruited these universities and courses, and we looked at the outcome on a few different variables. So let me show you what happened. We've got these two variables. One is final exam scores. How well did students do? And the other is how satisfied were students with their experience, right? And so in this study, students were randomized into one of these three conditions: an in-person learning experience, just as before in their college classrooms, a fully online experience where they were just taking the online course online, and a blended experience where they took the lectures online, but they came for discussion section in the classroom, right? And so here there's a few things to consider. One is that randomization is at the individual level. And two, there are different clusterings of units. There's a hierarchy to people, right? People are clustered by the university that they are in, right? And so that's important to consider in this design. And so, you know, one of the points here is that this is a very simple setup, right? It was very difficult to do, but the randomization approach is simple random assignment, right? If you're a student within a given course, sorry, I should clarify. It is really a kind of stratified random assignment because the randomization was within each university, right? If you were at University A enrolled in this course, we would randomize you to treatment or control, in-person, blended, and online, right? So it looks simple, but it is actually stratified because you have this structure of the different universities, right? And so that's something that then becomes part of the analysis. So this is a relatively simple example of a randomized experiment. Now, a similar kind of study can be performed using no experiment and just observational data. So here's an example where researchers looked at an online and on-campus university. They looked at the courses that they were offering either online or in person. And they estimated how much of an effect students have in terms of the grades that they get, depending on what kind of grades they were getting before, right? So you had a bunch, thousands of students in the study. You know what grades they had in the past. And the researchers here used the fact that the course schedules were public and there are sometimes conflicts where a student was taking one course and so they couldn't take this other course, which was in person or online. And so because of those scheduling conflicts, you had them be more likely to take the course one way or another. And that's an example of an instrumental variable, right? Where those scheduling conflicts affect course taking online or in person. And but they don't affect scheduling conflicts in and of themselves, don't necessarily affect what grades you get, right? They affect primarily whether you take the course online or in person. The other thing they had, a very classic instrumental variable, is distance to campus, right? If students were farther away from the campus, they had to drive farther, they were less likely to go and take in-person classes. It was more of a hassle. And so they used those two instrumental variables to estimate this result, which is unfortunate, which is that those students who had the prior GPA, they benefited the least actually. So this is how much of a so the benefit of taking it in person to online. So if they took it in person, they benefited more, but if they were taking it online, they benefited less. Whereas the students who had high GPAs to begin with, it didn't really make much of a difference for them. Yes, there's a question.
Yeah, I just wanted to ask, how do you know that distance to campus isn't correlated with the results?
Yeah. So this is one of the standard procedures when you try and identify good instrumental variables, is to see how well your instrument is correlated with the behavior of interest, which in this case is taking a course online versus in person, right? And so the researchers found that the distance does correlate with taking it online, which sometimes these variables make intuitive sense, and in this case it also empirically turns out sometimes it's a little bit more esoteric. The scheduling conflicts sort of is a bit more complicated than the distance, but so that's why it works.
Yeah, okay, thank you. Mm-hmm.
Sure. So let me show you another example. And this one I think is a great example for exemplifying a complex environment to do an experiment and a very maybe over-engineered experimental design to still get good causal inference out of it. So here's an online course, a MOOC, that was offered by Stanford, and it's an introduction to probability and statistics. And so our goal was to get more students in the course who are traditionally underrepresented. So this course, only very few women were taking the course, and fewer people with low levels of education were taking the course. A lot of people who were signing up had master's degrees, undergraduate degrees, even though the course is completely introductory. It requires almost no background information. Anybody could learn for free probability and statistics. Okay? And so what we wanted to try out is to test this diversity statement here, this welcome to the course, right? That's highlighted. Whether adding a diversity statement to encourage people would help increase enrollment from certain groups who are underrepresented. Okay. Now the problem is, because this is sort of this, it was never designed for experiments, this platform. The problem was that we could not randomize that if you come to this page, because at this point you're not even logged in to anything, right? You're just sort of a visitor to the page. We couldn't randomize whether or not you see the banner, right? The welcome statement. And so we used a different technique. Oops. This is the statement. We implemented it somewhere where it was very visible. And here's what we did. So we used a matched pairs and repeated measures design. So first of all, we started by selecting courses, right? The unit here is courses, all clustered by courses. We looked at all the courses that were offered at the time on the platform. We excluded courses that are sequences, because there might be, weird things going on. They're not independent of each other, right? If this is sort of, computer science 1, computer science 2, computer science 3. So we excluded those. We excluded courses that had very low enrollment, right? Because we don't get much data out of them of how people are enrolling. And we looked at, because we're very interested in gender here, we looked at courses that had more than 40% female enrollments. We then performed something called matching, and specifically threshold blocking, right? So we tried to find courses that are very similar among those courses that we had. Okay? We tried to find courses that had similar percent of women enrolled, similar percentage of women just the last month, similar percentage of people with college degrees, similar percentage of people who came enrolling from countries with a low human development index. And finding those pairs is not easy, right? The courses are very varied. And so at the end, what we were left with was 7 courses that formed these pairs that were very similar to each other. They were on different topics, but in terms of the user characteristics, which was the outcome we were interested in, who enrolls, they were very similar to begin with. Okay. And then we randomly assigned within each of those pairs, one of them to the treatment and one of them to the control. And we then alternated which one had which, right? Treatment means you have the statement. Control means you don't have the statement. And so for 2 weeks, if you were in the treatment, you got the statement and the control did not. And then we flipped it in the same pair, right? The control got the statement, the treatment got it removed. And so we did that for 6 2-week periods, okay? So you get 6 times 2 weeks, 14 courses, right? 7 times 2. Overall, in that time period, 30,000 students enrolled. Right? And here's some information on these different courses that were included in the sample size in the set. So you can plot the results like this. This is the way that you see everything that goes on. Here's our first matched pair and our second matched pair, and there's 7 of those. And you can see the different periods, and you can see where the default and the inclusivity statement, control and treatment, landed. And you can see that they flip, right? You can see that it's black and red, and then red and black, and so on and so forth, right? The other thing you notice is that the average levels of where the courses are, on the left, the y-axis is quite different than on the right, right? And that's because we chose them to be similar to each other, right? In the first place. And so you can then analyze these data using the appropriate methods for a paired design with repeated measures by looking at, in this case, randomization inference, looking at the various potential outcomes that could have come out of this design. And you can then find what the actual outcome is, here marked in red, right? How was the actual difference in this case, the difference in, I think, female enrollment in the course, right? There's 128 ways of randomizing in this scenario because we have these 7 pairs, 14 courses. You create the null distribution and you can do an exact test. And so this is what that looks like summarized for the 4 different outcomes that we were interested in, the different ways of looking at who enrolled in the course. And what we found was that there was actually one of these outcomes where adding the statement made a difference, which was for the proportion of students with lower SES enrolling in the course. Right? And so, even though we only had 14 units that we were randomizing, we were still able to get a p-value that is as low as 0.015, right, with a sample of 14 essentially, because of the design that we chose, right? Even though we couldn't randomize, even though we had all these limitations, by designing carefully the study, you can get a lot out of it. And there's some things that we didn't do perfectly in this scenario, right? The 2-week period might have been a little too long. We maybe should have let it run for longer. We could have had more courses in there. There's several things that one could improve in this design. But we were able to get this far with this one. There's a question, yeah.
Yeah, I have a question about quantifying the effect size. Does that make sense in online randomized experiments? Because in field experiments, sometimes it does make sense. Like in political science, we often say, like, shifting some variable will contribute to like a vote share, such and such percentage points. Do you do this in online experiments too? I was just
yeah, absolutely. So how you quantify the effect size depends a little bit on the context and the variable you're looking at. Right? Sometimes people like to use Cohen's d as sort of a standardized measure, which doesn't really make as much sense in much web data because it's distributed in a much more skewed way. So sort of this idea of shifts in normal distributions and standard deviation don't really apply. So percentages can be a good way. I think even the next slide, oops, no, not this one. But here you can sort of see as a way of quantifying the difference in proportion, right? And so the proportion of in this case, SES, low SES students enrolling in the course, and how much that increases or decreases in the course.
Mm-hmm.
So it's an absolute, one could just as well use a relative measure of effect size instead of an absolute measure of effect size.
Mm-hmm. So for physics, that's negative.
For physics, it's negative, exactly. Yeah. So here are the different, as you can see, one of them was significant. It was the lower SES one, where the actual value was at the very extreme that it could possibly be, in fact. And for the other ones, we were much closer to the center of the null distribution, right? And then we can look across these different topics. We looked at whether there were some topics that it worked better for than others, but we couldn't see any pattern in the different topics of the courses for whether they had more or less of an effect, right? So it seems to be just random noise distributed across these different courses. So this is one example that I want to give you for how you can use some of the techniques for designing studies in this context. And here's a relative effect size, which I mentioned before, right? We can look at how much percentage increase there is in terms of less educated students enrolling in the context, right? So 3% more students enrolling in the course, in those courses on average. All right, so let me show you one other thing before we open it up for questions. I want to make sure that we have enough time for questions. So this is an example of where we scaled up studies. So what I showed you before is sort of a contained experiment that we learned something from. One of the recent sort of efforts in online learning has been to scale up experiments based on interventions that seem to have worked well. And so we conducted a very large scale-up study recently, and I want to share some of the things that we've learned from that experience. So we had a few different interventions. I'm not going to go into detail as to what they are, because that would take way too long. The key here is that there are a few different kinds of treatments that we used based on prior work. So here's one which is the value relevance intervention. It asks you what's important to you and why, how that's related to finishing the course. We tried it in 2 courses beforehand, and we found some good effects. So here's what it looks like. This was from in the course survey at the beginning of the course. We gave you this if you were in the treatment. We didn't give you this if you were in the control. And it asked you to talk about what's important and how it relates. What we found here is that it helped students from less developed countries, right, who were in the control condition, persisting at only half the rate as students in more developed countries for various reasons. But that's the effect that we had found before, and we had replicated it in a second course. And so we had confidence in that intervention working well for that group of students. Okay, so that's the context for this value relevance intervention. Another one is a plan making intervention where students were asked to make plans for how they accomplish tasks in the course, right? This was tested by my colleagues, Mike Yeomans and Justin Reich, across 3 different courses. And what they found, this is what it looked like. Again, a little activity that gives you some tips for how to make good plans for how to finish the course. And what they found is that it increased completion rate and even the verification rate. So students paying for a verified certificate, not just a free one. Okay. Here's another one. This is a study that's kind of similar to the one just before with the plan making. It's just a different type that was developed by 2 psychologists. It works a little differently. It's called mental contrasting with implementation intentions. But importantly, we tested it across 2 large online courses, 18,000 students. And we found cultural differences in its effects. We saw that individualist cultures, there was a big effect in increasing completion rate as a result of that little planning exercise at the beginning of the course. It didn't work so well in more collectivist cultures than it did in individualist cultures. Right? We did that in one course, and we also replicated it in the other course. Okay, so this is, and so based on this, what I just showed you, we had a few different interventions. We had the value relevance intervention, the plan making intervention, and a few other ones. But I'll focus on those 2 to give you an idea of what happened once we scaled it up. Right? So before, we had each one tested in 2 or 3 courses. But now we took those interventions and we implemented them consistently across 247 courses. So that was a total then of 250,000 students who actually did the intervention, right? Not just, I mean, there was many millions of students who enrolled in the courses, but only some of them go to the page where the intervention is located, right? And so those 270,000, they actually engaged with it and they were assigned to conditions, right? Oops. So this is what the study setup looked like. It spanned over 2 years. It had several waves. At each point, we pre-registered, we collected the data, we tested our hypotheses, and we explored the data in order to inform the pre-registration for the next wave. Right? And so one of the takeaways that I want to share with you is that it was surprisingly difficult to find the effects that we had just found before, right? So wave 1, we had a certain set of hypotheses, we had certain things of exploration. We then said, okay, we find really strong patterns in wave 1. Let's make those hypotheses for wave 2 and see that we find them again, right? And when I say strong, I mean the p-value was low and the effect size was large, right? It didn't seem like it was just by chance that we came across it, but it's small. But more often than not, much more often than not, we were unable to replicate the results that we found, which gave me a whole new appreciation for the importance of context. Right? I mean, in some ways, the context was similar because they were all courses on the same platform. But in another way, time went on, and maybe the interventions didn't work as well for different groups of people in different kinds of courses. Right? And so over time, it was very hard to replicate any of the exploratory findings that we had before. And I think that really highlights the importance of replication in these settings. And it's much easier than it used to be to replicate experimental findings, right? Because of online platforms, we can just insert it again. So, one of my encouragements is to think about how you will replicate an effect already as you design the experiment, because this whole experience doing this study made me appreciate just how difficult it can be to replicate findings that look really solid in one study, even if it is with 50 courses. Once you collect data for another 50 courses, you might not find it again, right? So we had a few hypotheses for what might happen. And I'm not going to go into much detail, except that we did not find evidence for most of them, especially not at the effect size that we had initially found. Right? In the original studies, we saw these large to medium effect sizes. There were no large to medium effect sizes at all in the large scale-up study. Right? Once you look across so many courses, there's nothing that can actually be that strong on average across all of those courses. Right? So there's two things that we did find, and I think that gets back to the importance of clickstream data. Right? Very often, in the absence of clickstream data, we look at the big outcomes. We look at completion or some other bigger outcome. But one of the benefits of clickstream data is that you can look a little bit at the process of the kinds of steps that are important in order to get to the bigger outcome. Right? And in this case, it was just being engaged in the course. Right? Being engaged in the first few weeks of the course. If you're not engaged in the first few weeks, you're never going to complete the course, right? And so if our interventions help people be more engaged early on, it is a good first step. So you can think of this as a sort of as a process analysis to some extent, right? Did we increase engagement early on? And so what we found is indeed many of these interventions did increase engagement in the first 3 weeks, which we were able to infer by the clickstream data. We also saw some effects overall in completion based on the context of the course. So this goes back to the point of look at the outcome and who is affected by the outcome. So in this case, as you saw from before, the original study, there's this difference between more developed countries and less developed countries, right? In the control condition on the left, you see a big gap. But if you look at the treatment was only effective in these countries here, so in these courses here, where there was a big gap to begin with, right? In courses where there was no gap to begin with in the control condition, right? They didn't differ. The treatment was actually had a negative effect, right? And so if you throw them all together, you'll see no effect. But if you look at the context and how the context can moderate the effect of an intervention, you can start to understand more patterns, right? And courses in which there was a gap to begin with may have been a more difficult environment, a more threatening environment. It might have been sort of not designed well for an international audience. And so it might have been that is why in those contexts, the intervention that focuses on the relevance of values was more effective than in other courses. Okay. So this is an example of looking at heterogeneity, not just across individuals, but also across environments. And one of the big lessons for us from this was think about how you collect data on the context in which you're conducting your study, right? If there are many contexts, that might be valuable for you down the line, and might be much easier to collect that data as you're doing the study and collecting all the other data, not after the fact, when you have to go back and try and find out, well, what kind of course was this? Okay. So think about context as you design the study. I'll skip this part. We did some nice sort of prediction with it and did some more AI analysis of, can we do optimal treatment schedules? I'll skip that for now for time, but you can look it up. And so I'll just leave you with a few conclusions, and I want to jump into the discussion. Experiments are becoming cheaper to run and easier to replicate, right? Online platforms make it incredibly easy now to randomize aspects of an experience, to randomize interventions. And they also make it easier to do it again and see if it still works, if it works better or worse. And we should use that as computational social science. We should use that new affordance in order to understand causal relationships. There's lots of opportunities for combining analysis of clickstream data with experimental methods, either for creating better experimental designs by using that information to stratify or to match or to get pairs, or to understand early effects of an intervention, not just the long-term effects that it may have. So there's many ways of combining the two. And lastly, I think it's, I've been in this position many times, working with lots of different platform providers out there, online learning providers, and oftentimes the conversation is about data and data sharing, and that is great. You need the data shared in order to be able to do research on it. But don't forget to also have a conversation about the possibility of running experiments with them, right? In my experience, they're often open to it, especially if you pitch it in a way that is sort of clear and localized, and it doesn't disrupt the whole business flow, or especially if they're a startup, they don't have the resources, right? So think about what would be easy to implement. Oftentimes they're receptive to it, and it allows you to get data to perform causal inference in a way that's very robust. And finally, if you're somebody who designs new systems, right, who might create a little app for a certain purpose, we, for instance, just created an app to help students explore courses and major choices in college. Think about how you're collecting the data from it, for one, but also think about how you might implement experiments, right? How might you, from the start, integrate a platform for randomizing certain aspects of your system that you're creating, so that you can then collect experimental data from it from the start. Great. And with that, I thank you, and I look forward to your questions.
Yeah, thank you. It was so interesting. I enjoyed it very much, and I'm sure that we all enjoyed it. I have some pretty basic questions, but maybe some of you also have something to ask, please, guys.
And let me just say, you can ask about anything. It doesn't have to be about the things that I talked about. Any questions you have.
Yeah, Irina, please. Yeah.
May I have some clarifications? Well, I work with user data a lot, but can you please explain what is clickstream in your research design? Because I missed the first minutes of your lecture, so please could you provide an explanation?
No problem at all. So to me, the most basic fundamental clickstream data is time-stamped for each user, some event, and sometimes it has metadata in it, right? And that sort of, so you sort of just record it over time. It just collects in one big data file often, right? And then people tend to have abstractions of that, right? They sort of clean it up and make a version of it for different purposes. In educational settings, you also often have data that is, for each assessment, what scores were submitted. Sometimes that's sort of separate. You could put that into the category of clickstream data, right? It's slightly different, but it's kind of similar. It's more structured in a way. So that whole thing, the data that a system collects automatically, to me, is what I would define as clickstream data.
Thank you very much. So I understand you correctly. And well, you can obtain this clickstream from some learning services, right? Mm-hmm. Okay, thank you.
Yeah, so students are, we did a study recently on, and many people have done studies on dashboards based on Canvas or Blackboard or sort of, learning management system data that students use in college. And one of the interesting findings that, researchers often don't look for it, but they always report that students are surprised just how much data is recorded in those systems about them that they've never been aware of. Right. And so, there's a lot of data collected in education, and it's only recent that people are starting to use it for predictive modeling, for doing, dashboards, for doing various analyses with it to understand learning behaviors, educational, academic behaviors, and how they relate to oftentimes academic outcomes.
Yeah, this is actually what I was going to ask, but maybe there are some other questions. No, not yet. So I just, yeah, okay, yeah. Sangam, yeah.
I have a question. Thank you, Ren, for a wonderful session. Actually, I had a question related to the engagement data. So, for example, take an instance of an online class, probably due to kind of, there is like a possibility of missing out on the engagement data due to several number of reasons. But in that case, what I'm trying to understand is the clickstream data would be capturing, if the student is kind of using the LMS, the clickstream data, the interactions will all be captured. But what if the students are kind of using different other sources, like for example, the external website for a kind of for study purpose, or maybe reading books or reviewing notes. How do you incorporate this in your kind of together with the clickstream data? Because there could be some missing data which kind of complicates or invalidate the important measures that we ideally would like to have. So what sort of strategies do you kind of come up with?
Yeah, that's a very good point. And it's one of the other ways in which clickstream data can be insufficient for understanding understanding what is going on. There's a few different approaches that have been tried. So one that comes to mind is a colleague of mine, Mar Perez. She and her students, they developed a Google Chrome add-on that would record everything that's going on in your browser. It was, with consent, and some students participated in the study. And so she would, to answer that question, what else is going on while students are engaging in these online courses, look at all of the traffic, all the websites that they were on, to sort of get an understanding. And it provides some more information on how much time students spend on different pages and what they look at, opening Wikipedia to look something up and so on. So that's one approach that's not scalable, right? And a little creepy. Another approach is to do self-report and ask students what other resources they use. That's, of course, comes with the limitations of self-report usually. If you're in a classroom environment, you can do observational protocols. You can have somebody observe what students are doing and then take notes on that. And there's ways of coding that with good reliability. But again, it's not as scalable. So, the big benefit really of these platforms and the clickstream data that they generate is the scalability, right? And you just take into account the fact that it is incomplete, right? It's large, but it's incomplete. Let me give you an example of where we ran into that recently and what the trade-off is. We started looking at course consideration, how students are looking at different courses that they could be taking in college, and and how they go about finding out. So in the US, unlike in basically anywhere in the world, students have a huge amount of freedom as to what courses they take, right? It's sort of, the wild west of choices. And so, one of the concerns that people have is that that's just too much choice, right? And it's overwhelming what you should choose. And so we were interested in looking at consideration. So we built a platform where students can go and browse different courses and look at what's out there, right? And that gives us a good understanding of what they're looking at. But we don't see friends talking to friends and saying, hey, did you know about, CS 5260? And so that's some of the stuff that we don't observe. Now, you might argue, if you tell me about 5260, I might go at the platform, look up the course on there, and then I see it again. But you may also not, right? And so in the past, whereas sociologists have interviewed students, asked them to keep diaries of what courses they were considering, and that was sort of maybe more detailed, it was, it had its own limitations. Now we can look at it at scale. I now see for the entire university what courses students are looking at on the platform. But the trade-off is that there might be some interactions that are really important, right? The peer interactions, that I don't observe, right? And so that's the fundamental trade-off, I think, with these kind of web data.
Thank you. My other question is related to the causal inference. So when you talked about the causal inference, I guess you are referring to cause and effect, which we generally use in the managing complexity in the management context, right? So I guess the causal inference is what you are referring to, right? So for every cause, there is an effect, right? Something like that, right?
Yeah, I think the important distinction is between statistical inference and causal inference, right?
Mm-hmm.
So we can get lots of statistical inference, right, without knowing anything about where the data came from or how it was generated, right? But in order to do causal inference, you do need to know how the data was generated, how it came about. You know, maybe you generated it by, you know, assigning people and then they sort of provided data, or something else went on, like one of those quasi-experimental designs. And so for causal inference, the design matters, right? The process matters. Whereas for statistical inference, you know, you can calculate p-values all day, but it's not causal.
Okay, sorry, there's one more question which was related to one of the things that you talked about was related to the heterogeneity, right? Wherein you kind of specifically touched upon, you were actually, I don't exactly remember the word that you used, but I guess you were referring to a group of students who actually you were looking at some other courses that they might be from a philosophy background and they might be interested in doing something in engineering, right? So, what exactly the parameter that was of interest to you, or maybe kind of what you were exactly? Because I think I'm missing something here. Maybe if you can just because why I'm referring back, there used to be in higher school of economics there is something called as Mago Lego. So, for example, you as a student are given an option to choose a course from a different faculty. So I guess that is what exactly you were referring to, heterogeneity, when you said, right? But if you can just tell something more about it. Then.
Yeah, happy to. So this actually relates to what I was talking about before about course choice, right? So we created the system in order to, you know, for one, give students access to more information than they had before about courses, which was great use of the data that was just lying around before. It also allowed us to observe how students are considering. And thirdly, it allowed us to experiment with different ways of nudging students to see what kinds of information, what kinds of activities they respond to in their consideration and even enrollment process. Okay. So in this study, we asked students to reflect on their values, just like the value relevance intervention I showed you, and write about how taking courses outside of their major reflects what's most important to them, right? So we tried to, you know, prime them about their, you know, what's really what they care about, and to then get them to think about, well, you know, how actually maybe taking courses in philosophy relates to what I care about because I care about philosophy, right? Or culture, right? Maybe I should take a class in Italian because I like languages and I want to go to Italy. So, so that was the intervention. What was held constant was the recommendations of courses. All students got the same, you know, sort of carousel of course recommendations on the website that were curated carefully. And they were, you know, if you were a computer science major, you would not get computer science or engineering course recommendations. You would get recommendations outside of your major, right? And if you were undeclared, you got, you know, just sort of introductory courses in general. So that was the setup. The only treatment was the reflection exercise that was added to the recommendations. And so we found that students in the first term after we added this intervention were more likely to enroll in the recommended courses that were provided if they got that little reflection exercise to think about their values. In the following two terms at the university, same setup. We didn't change anything, just new courses for that term. The students actually went beyond the recommendations and enrolled in more courses also outside of their major, right? So if you took Italian 1 in the fall term, you might have then taken Italian 2, which we didn't recommend because it's not introductory, it's the second one, in the next term, right? So we saw sort of this sort of broadening of the effect. So we looked at who was affected by this. That was the heterogeneity analysis number 1. And we found that it was the students who had lots of spare time and spare units on to spend on other things. So engineering degrees tend to be very demanding, right? You have very few units that you can put in fun stuff or, you know, doing other things because there's so many courses that you have to take. So the farther away, the more academic freedom there was in a degree, the more people were affected by this intervention, the more they took exploratory courses that, you know, were recommended. But then we wondered, well, what courses do they take, right? So we see that people in the social sciences, humanities, arts, they take a lot of courses based on our recommendations. What do they go and take? And so we found that they take engineering courses as a result of the encouragement primarily, rather than, you know, courses in other humanities subjects, right? If you were sort of a sociologist, you didn't go and take philosophy courses or arts courses. You would, you know, more likely than not be taking engineering courses. So that was the setup. Does that clarify?
Yeah, thank you so much. I think you gave a very detailed explanation. Thank you so much.
Yeah. Nora.
Yeah, I had a question. I have a quite technical question about pre-registration. What do you pre-register? Like in your community of scholars, what you're supposed to pre-register? And if you deviate from the pre-registration, how do you defend your decisions then? Yeah, thank you.
Okay, yeah, that sounds good. So as you know, there's a few different philosophies on that. And I think in my community, so sort of education, the idea of pre-registration is just sort of slowly taking off. And there's a few advocates who are, you know, pushing ahead in that area, and that is great. So I don't think there's sort of strong norms yet, but we're hoping to get there. There's a lot of popularity in OSF or in As Predicted as two platforms for performing pre-registration. I've used both. My general advice to students of mine is always to just put as much of the materials that you have online as possible, right? Just, you know, as transparent as possible. You know, if you have measures, put them online. If you have, you know, anything that is there that, you know, doesn't cause any problems, to put it online. Now, in terms of the pre-registration, my opinion is that the more specific you can be about the analysis you'll perform, the better. So for this large project that I talked about, we actually had all of the analysis script, exactly line by line. We had a posted, and we had a sort of a fake data, like a synthetic data set that we generated with some simple assumptions so that we could run our analysis script on that and show what the results would look like, right? And so we had all of that posted in advance. Now, as you know, as I just mentioned, many of the hypotheses did not work out, right? And so it was important to us to be clear about that. You know, we said this was going to happen. It didn't, or, you know, that part did, but that part didn't. And then we talked about what we did find afterwards, right? In some cases, we said what we would explore, and maybe that's valuable to pre-register your exploration intent, right? To the extent that that narrows it down a little bit. You know, some people might say it doesn't really matter, but I think it's still good if you say, you know, I'm not confident enough to say this as a hypothesis, but I'm really interested in that thing and I'm going to be looking at it. So that can still be helpful. But I think that the important thing is to draw a clear line between what was pre-registered, what was found, and what was more exploratory. And so that's, you know, one of the things that, you know, we tried to do as best as we could, given sort of all the complexity of doing a study across 4 waves with 4 you know, the other thing that we learned was to sometimes the analysis is a complex approach to an analysis is not feasible once you scale it up. So when we were beginning, we had all these great plans for stratification and improving the design, and we implemented that. And it was a nightmare to analyze in the end because it just became so complicated across so many courses. And so we then, after the first year, we completely switched the assignment strategy and the analysis in order to be able to simplify. Because there's so many outlier cases that you can't really anticipate. And so that's something else that we learned from the experience to if you're scaling up, to keep it simple, because the data will be messy enough in the end.
Thank you so much.
Yeah, posting data is the one thing that I missed, and there are ways of posting data that preserve privacy. At least in the US, the one important thing with that is to try and get permission ahead of time from the IRB, so that they so that that's okay to post the data afterwards if it's sort of active collection of data. But if it's de-identified sufficiently, then sometimes it can be fine to still post it. Yeah.
So
Thank
do
you.
you have any other questions? Well, I was going to ask a question about your communication with all these multiple platforms. You already said that it's not impossible. So there is a way to to motivate them to provide you with an opportunity to use this data, even to change something on the site, so on the platform. So I just wanted to ask if it's always successful, or it's only in the 10% of cases you're able to get this kind of access. And also I wanted to clarify, I didn't get it in this in your study with this inclusional message. Why didn't you just randomize? So why didn't you do it like this? Some people could, this message could be shown only to some people, only to some learners and not to the others. Like in the survey, you can randomize the order of the items, or you can show something to one user and to another you show something else. So was it like a technical question? It's really hard to implement that, or yeah.
Let me answer that second one first. It was a technical limitation. So at that point, it was basically like you get to a university homepage. There was no login. There's you just sort of browsed through the page, and the back end of the platform, it allowed you to change what the course description was and what the title was and what the requirements were. Like you could sort of edit all the different pieces of information on the page, but that was it, right? You didn't know who was on the page. You didn't have any of that information. You didn't know what they were doing on the page. It was just sort of just like editing a university front page or your homepage, right? So we didn't have, that was a technical limitation. So the thing we could do was change the description to add in the image of that banner and take it out and put it in and take it out, right? And then we looked at enrollment, right? Because on the same page was the enrollment button. And so we could see once somebody enrolled, we knew their characteristics. And so we could look at how did enrollment change as a result of having it or not having it on the page. Yeah, so it was a technical limitation. If I could have randomized, I would have. But I think it's a good example of how even if you cannot, there are things you can do that that can give you good inference in a very limited setting by using the techniques of paired design, of repeated measures, and sort of combining them. The other question is a very good one, and it depends. Sometimes it works out and sometimes it doesn't. I think it's more often than 10%. Usually, one good way to go about it, in my experience, is to first just ask for some data. right? I mean, usually you have some kind of relationship, or there's an introduction to meet somebody there, and you can ask for some data, and you analyze it and you find some pattern, right? It might be clickstream data, and you find a pattern. And you say, oh, this is interesting. That suggests we should try that, right? What if we did this? And that's when you come to the experimental part, right? Once you sort of suggest that, oh, this would be a good thing to try. And the data you analyze may be clickstream, or it may be survey data, right? If you sort of see some concerning pattern in survey data, or how survey data relates to clickstream data, any of those work, right? But at that point, first of all, you verified that the data sharing process works, right? Because there's no point in you designing a whole experiment if you can't even get the data, right? So that's a good first step for everybody involved to see if that part of the relationship works. And then you can come to the platform with something of interest, right? A pattern that you found, at which point then usually there's more receptiveness around implementing experiment, because they're probably interested in the result as well. And then the real question usually is resources, engineering resources, right? To what extent does implementing that require a lot of engineering or induce some kind of cost? Right? So we recently had that experience with one platform where we then, based on some results, we proposed an experiment that would vary the cost of online courses, how much people would have to pay for the subscription. And that could have cost them a lot of money, potentially. It was also very hard to engineer because the pricing relates to so many aspects of the business. And so it was just not feasible to do that, right? And so other kinds of experiments can be much easier. And so that's something to think, before you propose something. Oftentimes you just get one shot. Think through, what kind of, how feasible is the design, and how could you change it to make it easier for them, right? In the case of the online course experiments, the big trick that we used that made it possible to do it with 250 courses was that the intervention was inside of a Qualtrics survey. And so all we had to do was get the course designers who were creating the courses for the different faculty every time they offered it to just insert an iframe or a link to the survey. Right, that was all we did. And we controlled what was in the survey. And so that way we could get the data, we knew what course it was in, and so on, right? If it had been more complicated than that, it probably wouldn't have worked. And so you have a trade-off there, right? On the one hand, now you only get people click into the survey, but on the other hand, you get lots of consistency in implementation as a result. And so that's something to consider.
Yeah, thank you. Well, do you have any other questions, comments? I also believe that we are running out of time, so maybe we'll finish here. Thank you for really a great talk. Yeah, you talked about really really important things. So it was not only the great overview about experiments, randomized experiments. I've learned a ton of new stuff, although I believe that I understand what randomized experiments are. And also you've talked about some really interesting things about how to combine this survey data and digital traces data, what we've discussed also today. So yeah, thanks a lot. Yeah,
absolutely.
Thank you.
It was my pleasure to come, and thank you for giving me the opportunity. And everybody, please feel free to reach out if you have any other follow-up questions or want to talk about any of these some more. I'm happy to chat.
Thank you. Yeah, that's really valuable. Yeah. Okay. So have a good day. I believe that it's like a middle of the day. Yeah, where you live. So yeah, have a nice day. Thank you. Yeah.
Take care.
Very much.
Bye-bye, everybody.
Yeah. Bye.
Thank you.